Propellant casted into the motor. For the liquid stage, we have the UH-25 and NTO4, the one used in PSLV second stage, the stop-on stages of GSLV, and also the second stage of GSLV. Whereas the cryogenic stage is a passive stage. When I say it's a passive stage, it basically means nothing is active in that. So, to be more precise, we will call it as an inactive stage, and whereas it has all the flight identical structures and interfaces.
P4 pulsar is on.
So liquid oxygen tank is filled with liquid nitrogen LN2, whereas the liquid hydrogen tank is filled with the gaseous nitrogen simulating the mass characteristics. So if we compare the overall external configuration of this experimental flight of LVM-3X mission, it's very similar to the flight configuration planned for the first developmental flight of LVM-3. The LVM-3D1 mission, which is scheduled to be taken up in the coming years, once we have the readiness of the C-25 cryogenic stage. And as this mission does not carry the live cryogenic stage C-25, the flight is going to be a suborbital one, because for any launcher, unless all the propulsion stages of the launchers performs nominally, we don't attain the orbital velocity. So if you look at the velocity share of each of these stages, primarily the strap-ons and the L110 stage gives half of the velocity, roughly around 5.3 kilometers. And to reach GTO, we require something around 10.2 kilometers per second velocity. So effectively, the C-25 stage is the one which imparts half of the velocity for the vehicle to be taken into orbit. So this mission is going to be a suborbital flight, where after the burnout of the L110 stage at around 125 kilometers, the cryogenic stage and the care module will be separated from the L110, and the further objective of this mission after the separation will be the recovery and the re-entry of the care module. The present launcher today, GSLV Mark III, which we are talking about, the purpose is basically to launch much heavier communication satellites, roughly in the range of 3.5 to 4 tons, and maybe in the future something like 4 to 4.5 tons. Now once the automatic launch sequence gets initiated, there will be host of activities that will be continuously checked out and cleared.
Minus 20 seconds.
Minus 20.
15 seconds. Ignition. 10. Enabled. 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, plus 1, plus 2.
So S200 ignited and safely cleared the umbilical pedestal.
7,
the vehicle is traveling across the umbilical tower.
बहुत सफल परीक्षण दोनों जो स्ट्रैप ऑन बूस्टर थे सॉलिड को प्रज्वलित आपके स्क्रीन पर आप देख पा रहे होंगे बहुत तेज आवाज हमारे कानों तक पहुंचती हुई अंतरिक्ष में सफर जारी रखता हुआ GSLV मार्क III की पहली उड़ान LV-MK प्रायोगिक उड़ान.
You can see this the GSLV Mark III blazing through the atmosphere, the two solid flames of S200 motors going through the atmosphere.
अवलोकित पथ बिल्कुल अनुमानित पथ से तरफ बढ़ता हुआ।
50 seconds.
बहुत तेज गड़गड़ाहट
55
चारों
seconds.
तरफ, केवल एक ही ध्वनि
200 performance normal.
रॉकेट।
We just heard the S200 performance normal. The time is 67 seconds, and vehicle has almost nearing 14 kilometers, so it has crossed the heavy dynamic pressure region. Now, if you look at the flight sequence, in the present flight sequence, the vehicle has to, will go for up to 114 seconds, and we will have the ignition of 110 stage.
लगभग 114 सेकंड तक ये प्रज्वलन जारी रहेगा और उसके
Ignited.
So L110 has been ignited. So there is going to be a little bit of overlap between the two S200 solid boosters and the L110.